Okay, so now we're going to talk about something called proportions. So we have things called ratios, and that's in the other video. And then we have these things in math called proportions. So proportions are pieces of things. So you know that you're dealing with a proportion anytime you have a word problem or anything like that that has to do with percentages. Anytime that you're dealing with percentages, we want to use proportions to solve it because there's actually a formula that we use to solve these issues. So if I paid $85 for something and it was 30% off, and I get home and someone asks me what the original price was, I don't know because I can't do that math backwards in my head. That's where this comes in. So here's the formula, and it's always going to stay this way, and it's important to remember, or to at least have written down so that you know it. I'm trying to figure out a place where I could write it so that you could see it well enough because I can't zoom in. So proportions do fall into algebra, just like ratios do, because you are trying to solve for x at some point. But how you do it is not that scary, I promise. So we're going to put two fractions next to each other. And this is how you solve all proportions. So it's part or a piece. So if you had one slice of pizza and there were 12 slices in the tray, one would be the part and 12 would be the total. So the formula is actually part over whole, but I like to write total in parentheses because sometimes that helps a little bit better. The 100 over here will always stay. Always, always, always. And then the percentage, this is where you fill in whatever the percent is. So basically the way that you solve proportions is that you're going to fill in 3 of the blanks. So that's a blank, and that's a blank. You're going to fill in 2 of them, and one of them will have an x, and you're going to have to solve for x. Now the way to solve this has everything to do with this equal sign. When you have an equal sign between two fractions, so you run into this with ratios, you run into this with proportions. Anytime you have an equal sign between two fractions, you're always going to do what we call cross multiply. So I'm going to show you how to do that with an example. So I just gave you that example about I paid $85 for something and the original price, it was 35% cheaper than the original price, something like that. So if I wanted to figure out what the original price was or how much the actual total was before my discount, I'm going to fill in the proportion. So first thing I'm going to do is I'm going to set it up. That's the easiest thing to do, and pop the 100 in there. I hope you can see the blue. Sort of. It looks like you can see the blue. I'll go over it with black. Sorry. I'm in a pretty big classroom at the moment. So the 100 always stays there. So I paid $85 for something. It was 30% off. And I want the original price. So now we have to fill in the other 3 spots. So the easiest way to start filling this in is to put the 100 first and then to see if you have a percentage. So we have a percentage. We have 30%. So let's look at the formula. That's going to go above the 100. So we have 1/2, we have the one fraction done. We have half the problem filled in. Now we got to worry about this side. So I paid $85, but it was on sale. And I'm trying to figure out how much the original price was. So would the original price be higher since it was on sale? Or would it be lower than $85? So if this shirt cost me $85, I would never pay that. But if it cost me $85, and that was because it was on sale for 30% off, if I didn't get it on sale, would this shirt have cost more than $85 or less than $85? The reason why I'm asking it that way is because usually the bigger number is going to go on the bottom because it's the whole, like the pizza. We have 12 slices of pizza. If you eat 3 slices, the 3 is going to go on the top, but the big number is going to go on the bottom. So, if I bought this shirt for $85 and it was on sale, that means the original price would have been higher. So when I fill this in, my 85 is going to go up at the top, and my X will go down at the bottom. So now we have to cross multiply to solve this. So that means we're going to crisscross. And we are going to multiply the 100 and the 85, and we're going to multiply the 30 and the X together. So grab a calculator if you need to. So 30 times X. Anytime you take a number and you multiply it by a variable, so any letter in math. I could have written a K here, I could have put in a D, I could have put a T. Doesn't matter what the letter is. The letter here is also called a variable. I know that variables are also used as like topics in two-way tables, so just don't get that confused. But anyway, anytime you multiply 30 by a letter or a number by a letter, it's going to be the number and the letter together. So 30 times X is 30X. And then we're going to carry down that equal sign, and we're going to multiply the other way. So 85 times 100, pop it in your calculator. So we should end up about here. So we know that 30 X's are 8,500, but we still, so that means that 30 shirts would be 8,500. But we still need to figure out what one shirt is. So that means that we have to divide, because we want the number to get smaller. So if 30 of these is 8,500, now what we need to do to just get one X is we need to divide both sides by 30. Because when you have an equal sign, what you do to one side, you have to do to the other. So this will cancel completely, and the X will come down, because 30 divided by 30 is 1. Anytime you have a 1 in front of an X, you don't write the 1. You can, but it's really not right. Then on this side, we need to divide 850, or 8,500, by 30. Since both of these numbers end in 0, you can cancel out the zeros, and I can put in my calculator 850 divided by 3. It's the same thing. If that's too confusing, then do the whole number and do 8,500 divided by 30. So let's see what we get. Because I can't do that in my head either. Now, just because this 8,500 is a big number, don't get scared by it. Don't be intimidated by it. We have big numbers in math. That's okay. But there's always a way to work with them, and there's always a way around them. So we're dealing with money here. So we should have gotten this answer of 283. And then you probably got 0.33333333333, which in math we say 0.3 repeating. But Since we're talking about money, we're going to go to two places. And that's your answer for this one. All right, so let's try some. Now, the other thing with proportions is that a lot of the times if you get, so when you get into much harder math problems, like word problems, there are a lot of times where proportion word problems are they're going to do one of two things. You're either going to need all of the numbers that are part of it, or they're going to give you way too many numbers that you don't even need at all. Okay, so I have 70. I have 70 marbles. Um, 30% are blue. 60% are red. 10% are clear. How many blue marbles do I have? So I'm going to read it again in case you're writing this down, which I hope you are. I have 70 marbles. 30% are blue. 60% are red. 10% are clear. How many blue marbles do I have? So we know that this is going to be a proportion problem because it's got percentages in it. Whether it asks you to find a percentage, any mention of a percent or a percent sign, automatically a proportion. But the way to work this out is before we even dive into the formula, is what are we trying to figure out? And which of the two scenarios is it? So do we have more numbers than we need, or do we need all of the numbers that are in this problem? So let's start with what is our goal? What are we trying to figure out in this problem? So our goal is how many blue marbles. That's what we're trying to figure out. So we have blue marbles, red marbles, and clear marbles. If we're only trying to figure out blue marbles, do we care how many marbles are red? Because the problem's not asking us for it. So we could just cross that right off. So now that's one less thing to make you worried or make you scared. Do we care how many of the marbles are clear or see-through? Well, the problem says they want to know about blue marbles, so we don't care about how many are clear either. So now that we got rid of the stuff that we don't need, and we've figured out what we are trying to figure out, now we can set up the equation. That's what this is called, is an equation. All right, so we're going to set this up the same exact way. The 100 is always going to go in the bottom right corner. Okay, so let's look for our percentage. Do we know what percent of the marbles are blue? Yes, we do. 30%. So it's going to go where the percent sign is. Okay, so now we have to fill in this side. So I have 70 marbles is the first line of this. And then here's the breakdown of what the marbles are. So does that mean, do you think that you have 70 marbles total? Or not? You have 70 marbles total, because this is the breakdown of what the 70 marbles are. So where do we put our total? So 70 is going to go here on the bottom. So we have 3 spots filled out. So the thing that we're looking for, we're going to put a letter there. I'm going to use a D. Doesn't always have to be X. It doesn't always have to be Y. Most math teachers just always use X. And to be honest, I really don't know why. Okay, anyway. All right, so now we're going to cross multiply, remember? So that means we're going to multiply the D times the 100 and the 30 times the 70. So let's start with the letter. 100 times D is going to be 100D. So it's basically just the number with the letter. And then the equal sign is going to come down. And then we have to multiply 30 by 70. So grab your calculator. And you should get 2,100. So now that's for 100 of them though. I need to figure out just what one single D is. So we have to divide both sides by 100. So basically whatever number is in front of the letter, that's what you're going to divide both sides by. So this is going to cancel out, and we're going to have a D left over. So D is going to equal, calculator, answer? D is going to equal 21. So the thing with proportions is it just matter, it's going to change where you put the letter X. That's pretty much it. So we already did a problem where X was down here. We just did a problem where it was up here. And oftentimes you do a problem where you're trying to find the percentage so that X will go where the percent goes. So that's the difference between ratios and proportions. Even though ratios are going to end up looking like this part, ignore the formula, but even though ratios are going to end up looking like this after you take them out of the dots, it's not about filling in a formula like this. But the mathematical steps are the same once you get them into fractions. So I hope that this helped. Of course, ask me questions anytime you need them. And I'm going to stop now.